Hello students, Professor Piggy here. Today we trot confidently into the secure pasture of application development and deployment, where wise developers build sturdy barns and clever IT security managers make sure no splinters are left for the wolf to exploit. Applications are powerful tools, but without secure coding practices, they become open gates inviting trouble. For your CompTIA exams, you must understand not just what these protections are, but why they matter and how they stop attacks before they begin. Let us begin with input validation, one of the most important defensive techniques in secure coding. Input validation is the practice of checking data for validity before using it in an application. It ensures that only properly formatted, expected data is processed. This prevents attackers from sending malicious input designed to manipulate or break the application. Improper input handling is one of the most common web application vulnerabilities. When developers fail to validate input, applications become susceptible to attacks such as buffer overflows, SQL injection, dynamic link library injection, and cross-site scripting. The wolf loves sloppy input fields because they allow him to sneak in malicious commands disguised as normal user data. Strong validation slams that door shut before he can even scratch at it. Effective input validation includes verifying proper characters, blocking embedded HTML code, preventing dangerous characters, and implementing boundary or range checking. For example, a phone number field should only accept numbers and possibly dashes in a defined format. A quantity field should enforce maximum purchase limits. These controls ensure that unexpected data is rejected before it reaches deeper components of the system. Client-side and server-side validation both play important roles. Client-side validation executes in the user's browser and provides quick feedback, reducing unnecessary server requests. However, it is not secure by itself, because users can disable scripts or intercept and modify data before submission. The wolf can easily bypass client-side checks if no further protection exists. Server-side validation executes on the server after the data is submitted. Because the server controls this process, it cannot be bypassed by simply disabling browser features. Server-side validation ensures the application never processes invalid or malicious input. Exam candidates must also know that dynamic analysis with fuzzing and package monitoring are key vulnerability identification methods listed under Objective 4.3. For exam purposes, remember clearly that server-side validation is more secure than client-side validation, and using both provides performance and protection. Developers also use techniques such as HTML, encoding, or escaping to sanitize output. Special characters like the greater than symbol can be converted into encoded equivalents so that browsers interpret them as harmless text rather than executable code. Libraries such as the OWASP Enterprise Security API, provided by Open Worldwide Application Security Project, help developers implement standardized security controls, including input validation and encoding. These tools help ensure consistency and reduce human error. Now we must discuss race conditions, which occur when two processes attempt to access or modify the same resource simultaneously. A race condition can lead to inconsistent data or unintended behavior. In secure development, concurrency control mechanisms prevent multiple entities from altering the same value at the same time. Without proper locking or transaction controls, unpredictable results may occur. A specific type of race condition is the time of check to time of use vulnerability, often abbreviated as TOCTOU. This occurs when a system checks a condition, such as access permissions, and then performs an action later. If an attacker modifies the resource between the check and the use, the system may perform an unauthorized action. The wolf attempts to slip into that tiny window of opportunity, but proper synchronization and atomic operations prevent his mischief. Proper error handling is another essential defense. Error and exception handling routines Ensure that applications manage unexpected conditions gracefully. Instead of crashing or exposing sensitive debugging information, the application provides a generic message to the user while logging detailed information internally. This protects system integrity and denies attackers valuable reconnaissance data. Code obfuscation is sometimes used to make source code more difficult to understand. It may rename variables, remove whitespace, or encode strings to reduce readability. However, security through obscurity is not considered a reliable primary defense. Skilled attackers can still reverse engineer obfuscated code, so obfuscation should only supplement, not replace, strong security controls. Software diversity introduces variability into compiled programs so that identical source code may produce slightly different binaries. The goal is to make widespread exploitation more difficult, because an attack that succeeds against one compiled instance may fail against another. This approach adds complexity for attackers, forcing the wolf to adapt repeatedly rather than reuse a single exploit. When organizations outsource code development, they must carefully evaluate risks. They must verify that the code functions correctly, follows secure coding practices, and contains no malicious backdoors or logic bombs. Contracts should address long-term maintenance and updates. Without proper oversight, an organization could unknowingly deploy vulnerable or intentionally harmful software. Protecting data is central to secure application design. Data at rest, data in transit, and data in processing must all be safeguarded. Encryption commonly protects stored and transmitted data, while secure memory handling reduces exposure during processing. Applications should clear memory buffers after use to prevent unauthorized recovery of sensitive information. HTTP headers also contribute to application security. Response headers such as HTTP Strict Transport Security, Content Security Policy, and X-Frame options instruct browsers how to handle content securely. These headers reduce risks such as downgrade attacks, content injection, and clickjacking. Proper configuration strengthens the communication channel between client and server. Note that X-frame-options is the correct header name with hyphens as listed in OWASP best practices. Cookies must also be protected. A secure cookie includes the secure attribute, which ensures it is transmitted only over encrypted HTTPS connections. This prevents attackers from capturing session information over unencrypted channels. Without the secure attribute, session hijacking becomes significantly easier for an attacker monitoring network traffic. Code signing uses digital certificates to verify the authenticity and integrity of software. A developer signs the application with a private key, and users verify the signature with the corresponding public key certificate. Code signing provides assurance that the software originates from a trusted source and has not been altered. If malware modifies the code, the signature validation fails. Testing and reviewing code are critical quality control measures. Static code analysis examines source code without executing it, identifying potential vulnerabilities through manual review or automated tools. Dynamic code analysis evaluates the application during execution, often using fuzzing techniques that send random or unexpected input. Sandboxing isolates applications in controlled environments to observe behavior without risking production systems. Software version control tracks changes to code over time. It documents who made changes, when they were made, and what was altered. Version control systems allow developers to roll back to previous stable versions if new updates introduce issues. This control prevents unauthorized modifications and supports accountability throughout the development lifecycle. A secure development environment separates development, testing, staging, and production systems. Each stage operates independently to prevent accidental impact on live services. Quality assurance processes apply throughout the lifecycle to ensure the application meets functional and security requirements. Isolation between stages reduces the risk of unintended exposure or instability. Databases introduce additional considerations. Structured query language, or SQL, is used to interact with relational databases. SQL injection attacks occur when attackers manipulate input fields to insert malicious SQL commands. A common example uses the phrase or 1 equals 1 to create a condition that always evaluates to true, potentially exposing all records in a table. To prevent SQL injection, developers must implement strong input validation and use parameterized queries or stored procedures. A stored procedure is a predefined group of SQL statements executed as a unit. Parameterized stored procedures treat user input as data rather than executable code. This distinction prevents malicious input from altering the structure of the query. Web server logs provide valuable insight into both normal and abnormal activity. Administrators can review logs to identify suspicious patterns, such as repeated injection attempts or unusual query strings. Centralized logging systems and automated alerts enhance detection capabilities. Monitoring logs helps detect when the wolf is pacing outside the fence long before he finds a weakness. Secure application development is not a single technique, but a layered approach. Remember that OWASP guidelines and stored procedures with parameterized queries are core exam expectations for preventing SQL injection and XSS. Input validation, error handling, encryption, code review, environment separation, and logging all work together to reduce risk. When these controls are properly implemented, attackers find themselves frustrated and outmaneuvered at every turn. And that, my brilliant students, is how we keep our digital barn sturdy, exam-ready, and wolf-proof. If you found this lesson helpful for your CompTIA journey, be sure to like and subscribe for more secure wisdom from Professor Piggy. Oink!